Hi, Assalamualaikum warahmatullahi wabarakatuh. So for today, I'm going to make a presentation about Soil Engineering Laboratory Mini Project. For this project overview, 3 experiments was conducted. The first one is particle density and specific gravity test. The second one is liquid limit of soil test. The third one is plastic limit of soil test. All of the 3 experiments include adding 15% of POFA as an additive. So what is POFA? POFA is a palm oil fuel ash, which is an industrial byproduct which produced by burning palm oil shell and has as fuel in a palm oil mill boiler, produce steam to generate electricity for the palm oil extraction process. For this mini project background of study, soil stabilization is the chemical or physical treatment of the engineering characteristic of the soil. The method is used to improve the soil capabilities, as for examples, permeability, compressibility, durability, plasticity, and mechanical strength. The objective of the laboratory's project is, as for the particle density test, is to determine the particle density and specific gravity of soil. As for the additive limit test, is to determine the liquid limit and plastic limit of soil. The first experiment is the particle density test. The apparatus needed for this experiment is the density bottle with stopper, wash bottle with de-aired distilled water, desiccator with vacuum set, and weighing balance. For the procedure of this laboratory, step 1, take empty density bottle with stopper and weight it, record it as M1. You need to make sure it dried and clean before you weight it. Step 2, about 10 to 20 grams of soil sample were put into the density bottle, record it mass as M2. Step 3, 15% of palm oil fuel ash from soil weight was added into the density bottle along with the soil sample. Step 4, about 10 ml de-aired distilled water poured into the density bottle and soak the soil. Left it for 2 to 10 hours, then pour it half full, remove the air bubbles by using a partial vacuum. Step 5, the density bottle will completely fill by water and put the stopper on. Step 6, cap the bottle in the desiccator for 1 hour and take it out and weight it as M3. Step 7, clean the density bottle and fill it with water only, weight it and record it as M4. So this is the result of the particle density test. The formula stated was the formula used to calculate the result of the particle density test. The discussion for particle density test. The specific gravity from the experiment I obtained is 2.538 and 2.719 and no additive added in the sample, while for the sample with 15% of POFA is 2.438 and 2.727. This result was differed due to the effect of POFA, rather the amount of the additive or the particle used in the experiment. The decreasing in the specific gravity value and particle density when POFA is added can bring too many consequences. The permeability will increase, so do susceptibility to erosion. The mixture will have lower strength and durability, making it not suitable to use for any construction. As for the safety precaution, drying the density bottle fully so there is no additional value added to the result. The digital meter for the weighing of soil sample was not in state of instrumental error. For the second experiment is the additive limit test that include liquid limit test and plastic limit test. As for the liquid limit test, I used the Casagrande method. The apparatus used in this experiment is glass plate, Casagrande device, wash bottle with de-aired distilled water, spatula and palette knives, moisture cans, drying oven, grooving tool, and weighing balance. Step 1. 200 grams of soil and 15% of POFA were taken and placed onto the glass plate. Mix the soil thoroughly until it appeared as smooth, uniform paste. Step 2. 3 empty moisture cans was labeled and weighed as M1. Step 3. Adjust the apparatus by checking the height of drop of the cup. The point of the cup that comes in contact with the base rise to a height of 10 mm. Step 4. A portion of previously mixed sample will place into the cup and squeeze it down to remove the air pocket. Make sure the depth is about 10 mm at its deepest point. Step 5. Cut a clean straight groove down the center of the cup using the grooving tool. Step 6. Clean the underside of the cup and start dropping the cup until it comes to contact. If it exceeds 50, do another sample mixing by adjusting the water content. 7. Take the sample by using a spatula from the edge to edge of the soil pad. Weight it and record it as M2. Leave it for 16 hours. Step 8. Remix the entire soil specimen with increasing water content so the number of drops required to close the groove decreased. 9. Oven dry the sample for 24 hours. Once it's complete 24 hours, weight it and record it as M3. This is the data for the liquid limit test. And this is the graph for the liquid limit by Casagrande method for control sample and additive sample. The last experiment conducted is the plastic limit test. The apparatus used in this experiment is glass plate, wash bottle with de-aired distilled water, spatula and palette knives, moisture cans, drying oven, and weighing balance. The procedure of this experiment. Step 1. An empty moisture can was labeled and weighed, recorded as M1. Step 2. Take the remaining 20 grams of soil sample from the liquid limit test before. Add water until it can be rolled without sticking to your hand. Step 3. Roll it between your palm and finger and shape it into a ellipsoidal mass. If the thread shaped broken into several pieces, re-roll the sample until it can no longer be rolled into 3 mm diameter thread. 4. Weight the soil sample and record it as M2. Step 5. Oven dry the sample for 24 hours, and once it's done, weight it and record it as M3. This is the data obtained for the plastic limit test. The plasticity chart of the test. So this is a summary of the attribute limit result. The discussion for attribute limit test. The result obtained can be defined when POFA was added as an admixture in the attribute limit test, which led to the increasing of the plastic limit, liquid limit, and plasticity index of the soil. This was due to higher plasticity and bonding effect of POFA that need high water content for soil to show plastic and liquid behavior. As for the safety precaution, avoid using your hand to mix the soil particle in water since it probably will change the moisture of the particle, except for plastic limit test because the procedure demands you to crumble the soil until it cracks. The second one is the digital meter for the weighing of soil sample was not in the state of instrumental error. So what is the advantages of this mini project or good things that you get when you stabilizing soil? The first one, that you can save waste. You don't need to import the new material when the soil on site can be used after a simple treatment process. Second one, that you can save money. Less material is needed for the layers above the soil that stabilize. You can consider the right material that can greatly improve the performance of soil compared to unstabilized soil. The third one is to protect environment. Less transportation needed if soil are treated the right way. The last one, that you can save times. Shorten time to complete the project when soil is already stabilized. I think that's all for my presentation today. Thank you very much for watching.